Okay, we're going to work through another example here. This is from, well, it's from 9.8, example 3. So it's not really a difficult problem. It's not lengthy. It's just I wanted to remind you on this one that sometimes we might find it convenient to change the index of summation. So, for example, here's our problem, and this is our series. And if we find the first few terms, we're going to have x over C0, 1 factorial, and then you'd have an x. Notice this goes up to 3 as a power when n is 2. And we have a 3 factorial down here. And then the next one is a 5, and a 5 factorial, and so on. So if you notice what's happening to the exponents, and you can see that we don't have to leave this index starting at a 0. We could write it beginning at 1. Okay, and what that would do is it would force us to write this as 2n minus 1. Since when n is 1, our first, this will remain odd. 2n minus 1 is odd. And this will remain odd, and this first one will start off with a 1. 2 times 1, 2 minus 1 is 1. And we can do the same thing in the denominator, make this 2n minus 1 with a factorial. So was there an advantage to that? Not in this case, but we don't really have a context for this problem. But in other ways, this might be valuable to be able to shift that and begin it at 1. So without a context, I can't show you why that's going to be an advantage. But now sometimes by making that switch, we've already seen this, that we can rewrite the expression in here and it becomes simpler. This one really didn't change much. It's about the same as complicated as the other one, so that didn't really change. So the only advantage here was that I began with n equals 1, if that's even an advantage. But notice the first few terms here. You'll still start out with the x, because it'll be x, 2 minus 1 is 1, and 1 factorial. And the next term would be 4 minus 1 is 3, and you have a 3 factorial, and so forth. But notice it looks different. Up front here, it looks different. Different expression, different index. Okay, so you can always shift the index. Now here I shifted it to n equals 1. We could have shifted it to anything we wanted, really. You just have to do the associated algebraic change in here. So for example, if you wanted to go to n equals 2, then you would have to start off, let's see, we'll have to have x to 2n. Let's see, we'd have to make this a minus 3, because that would be a 4 minus 3 is 1, and then 2n minus 3 down here. So again, no real advantage to that, but notice this would be the same series. This would be 4 minus 3 is 1, and then you'd have 3, which is 6 minus 3 is 3, and you'd have the same thing. So this is called shifting the index.